Chaos and the World of Chemistry. Have you ever wondered what the world is made of? What are air, water, food, and even our bodies made of? Chemistry began with questions like these. Chemistry is the study of matter. But chemists do not only ask what matter is made of, they also study its shape and structure. Why is this? Just as the structure of a building determines whether it serves as a school, hospital, or apartment, the structure of a molecule determines the properties and functions of a substance. Then how can we create a material with the structure we want? Even the best idea has little value if we cannot make it. That is why chemists study chemical reactions, the process of creating materials. A chemical reaction is, simply put, a process in which atoms change places. Atoms break existing bonds, form new ones, and become different substances. However, atoms cannot react freely under any condition. Just as crossing a high wall requires effort, a reaction needs a certain amount of energy. We call this energy activation energy. But do all molecules have the same energy? No, they do not. Some molecules move slowly, while others move surprisingly fast. It is much like a playground, where some people walk and others sprint. Among countless molecules, a small number with higher energy react first. This shows how a tiny difference can create a large result, much like chaos. That is why we can find the characteristics of chaos in chemical reactions. For example, what happens when we drop a single drop of ink into water? The ink gradually spreads out. If all molecules moved in exactly the same way, the ink would spread in a very regular pattern. But in reality, countless molecules collide and change direction, making it difficult to predict exactly how the ink will spread. One fascinating example of chaos in chemistry is supercooling. Water normally freezes below 0 degrees Celsius. However, when very pure water cools slowly and remains undisturbed, it can stay liquid even below 0 degrees Celsius. What happens if a small shock disturbs supercooled water? Surprisingly, it begins to freeze almost instantly. A tiny disturbance triggers a dramatic change. This also shows a key feature of chaos: extreme sensitivity to initial conditions. Chemists care not only about what a substance becomes, but also how fast it changes. Why is that? Think about an atomic bomb and a nuclear power plant. Both use nuclear reactions, but the results are completely different. An atomic bomb releases enormous energy in a very short time, while a power plant releases that energy slowly to generate electricity. In the end, the difference comes from the reaction rate. Most people know that water is made of hydrogen and oxygen. But if hydrogen and oxygen are mixed together, do they automatically become water? Surprisingly, they do not. The reaction needs an energy source, such as a spark, to begin. A spark gives the molecules their first push. Once the reaction starts, it continues in a chain, producing water. A small beginning can create a huge change, much like a snowball that grows larger as it rolls downhill. So how do chemists control reaction rates? The simplest way is to raise the temperature. As the temperature rises, molecules move faster and collide more often. Another way is to use a catalyst. A catalyst is a special substance that helps a reaction occur more easily. Do catalysts exist inside our bodies? Yes, they are called enzymes. Without enzymes, digestion would be extremely slow. But enzymes help break down food quickly and turn it into the nutrients our bodies need. Chemistry is not simply the study of matter. It explores a world of complex changes created by invisible atoms and molecules. Within that world lies the principle of chaos, where small changes can lead to unexpected outcomes. Have you ever watched ink spread through water or seen supercooled water freeze in an instant? Perhaps those fascinating phenomena carry traces of chaos.